12.2 for us is going to be all about pyramids. Now you kind of, if you look at the very cover of your book, there should be a pyramid on the book. Has anyone ever been to Las Vegas before?
Oh yeah.
Seen the pyramid Luxor Hotel? Has anyone actually been to Egypt and seen the actual pyramids of Egypt, right? So pyramids have been around for a while. They're very interesting geometric figures. And so we're going to be talking about pyramids today. We're going to be talking about the area, the volume, all kinds of the parts of the pyramid and everything that a pyramid has to offer. Okay, but first here's the formal definition, kind of boring, but we have to sort of say it so we at least understand. So the pyramid is a solid figure, meaning, you know, there's no holes in it or anything. Solid figure with a polygon base and triangular faces that meet at a single point. So I've given you right down there, those are two examples of pyramids, even though they look kind of different. What's the difference in the picture of the pyramids that you see down there?
So they're not like they're 3D.
Yeah, they are 3D, yeah, because pyramids are 3D. One has more sides, okay. They have different polygon bases, okay. The one on the left is a rectangular pyramid. The one on the right would be, how many sides does the base have? 1, 2, 3, 4, 5. So a pentagonal pyramid, right? So we're going to learn how to name pyramids in a moment, but both of those that you see, those are both qualified as pyramids, okay? Those both qualify as pyramids. Here's another one that I could draw for you, and it'll look like this. Okay? Now look at that one. And then I always like to color in my bases. Sometimes I'll highlight the bases. It's a little bit easier for you guys to see. There's the base for that one. Here's the base for this one. Everybody should have there should be highlighters available to you if you also want to do this.
Should I draw?
You don't have to. If you get it, then you don't have to. But the main point that I'm trying to make here is that all three of these are considered pyramids, even though they have different bases and different number of faces. Right? But they all count as pyramids because the definition has to be a solid figure, has to have a polygon as a base, the faces are triangular, and they all meet at a single point. Is that fair enough?
Yeah.
Okay, so I'm going to just shrink this down so I have a little bit more room to write. And I'm going to talk about some key points here. They have the bases, right? So these down here, the highlighted pieces, those represent the bases. That's the base, kind of like where the triangle, the pyramid sits. And then this, the triangular faces, I'll highlight one of them for you. Like this front face here, even though it's going to turn green right there, I do that. This front face is a triangle. This front face of this pyramid is a triangle. And this face over here, this is also a triangle. So the faces are triangles. That makes sense to us. And then meeting at this single point. This single point right here is this one point right here, this point over here, and this point over here. That has a name, a very specific name. Maybe again, guesses, starts with a V. Yep, you got it, the vertex. Okay, so where all the faces meet, it's called the vertex, and that's that single point that we're talking about. So that right there is an introduction to a pyramid. So practice how I taught you how to draw it. So make the V, go parallel, scattered, parallel, scattered, bottom up, connect, connect, boom, and I am going to highlight the base. Okay, there you go. Okay, everybody cool with their pyramid? You guys have mad pyramid drawing skills now? Okay, the altitude. So we're going to start, I'm going to do a big red line. We're going to start at the vertex, and we're going to go straight down to the center of the base, perpendicular. Center of the base. This piece right here is called the altitude. No, this black line is an edge, okay? That's a lateral edge. This altitude is the line that's inside the pyramid. It's going straight. It's almost like if you had a piece of string and you attached it to the inside of the pyramid and let the string hang down and touch the base. That's where the altitude would be. That's the altitude. So it goes from the vertex straight down to the center of the base, okay? Perpendicular to the base. So the altitude is always perpendicular to the base. That's what's known as the altitude, and that's how we measure the height of a pyramid. Okay? So that is how we measure the height of a pyramid. It's that piece right there. It's from the center of the base to the top of the vertex. Okay, the question is, how do we name these pyramids? They're all different. Well, what's different about them? Yes, the bases are different, okay? So how do we name pyramid number one? Well, first of all, every vertex needs to be labeled. So I'm going to label each one, okay? I'm going to call this, I'm going to label this in green so you can see. The vertex at V, and then I'm going to go A, B, C, and then the vertex in the back, I'm going to call D. In pyramid number two, I'm going to label the vertex R, and then I'm going to label this P, Q, and S. And then in pyramid number three, I'm going to label the vertex X, and then call this Y, Z, P, Q, M, and then L in the back there. So in order to talk about a pyramid, to name a pyramid, we have to have all the vertices named. So I just gave them letters. Now let's talk about pyramid number one. I'm going to do this in this blue for you. The first thing we do is we describe the base. So how would you describe the base in pyramid number one? Square or rectangular, right? So we have a rectangular pyramid. So we say rectangular pyramid, then we start at the vertex. So vertex is at V. We start with that vertex. Then we put a little hyphen. Yes?
Sorry, for number 3, is the base a pentagon or a hexagon?
We'll get there. Okay?
Well, I'm just knowing so I can draw.
Yeah, we'll get there. Okay, we'll get there. Rectangular pyramid, vertex V, and then what? We have to go around the base in an order. So we can go in any order we want. We just have to go in consecutive order. So I could call this DABC if I wanted to. DABC. What would be another way I could describe it? ABCD. I could also do that. You just have to go in an order around the base. Okay? So this is how we describe pyramid number one. That's how we describe it. So let's take that same logic and let's describe pyramid number two. Very good. Triangular pyramid.
How is the other one rectangular? You look at the base, right?
I can't spell this word.
What squares are rectangles?
Triangular pyramid. What's the vertex?
R.
R. Then what order do you want? Okay, PSQ. I'll take that. Now, you said to answer your question. What's the base of pyramid number three, guys?
Pentagon.
This I got 1, 2, 3, 4, 5, 6. Does that look good?
PSQ. Wouldn't it be Q, P, Q, S, Q, and A, B?
It doesn't matter. I just have to go in order, in any order around the back. I just can't say, well, it doesn't matter for that one. It's only 3 points.
What would it be, hexagonal?
So, how many bases, or what's the polygon of the base for pyramid number three? It's got 6 sides. So what would it be? Hexagonal. There you go.
I don't know how to draw that, so I'm gonna leave that one out. I'll actually write the name of it, but
Hexagonal pyramid, and then what do we do now? X hyphen. How do you want to go?
L, M, Q.
L, M, Q, P, Z, and Y. So E said yes, that was a hexagonal pyramid. And this is a triangular pyramid, and then I have a rectangular pyramid. So we have to be able to, when we talk about pyramids, we describe the base, right? And then we start the vertex and then go around the base in any order as long as you stay in an order around the base. Okay, so we already know about the base of a rectangular pyramid. We already have that. I've colored that in. That's the base of the rectangular pyramid. We're going to talk about lateral faces and lateral edges, right? You can probably figure out. We have the base, right? Let's talk about a lateral face. The lateral face is one of the triangles. So I'm gonna do my best to color this one. Now it's gonna go. Yeah. So if I erase the yellow, there we go. Okay. So this part right here, this is a lateral face. It's a face that's on the side. So this part right here is a lateral face. Okay, that's a lateral face. So if that's a lateral face, what do you think a lateral edge is?
The edge of the line.
We have one of these, right? Wherever they meet, this would be a lateral edge. Okay? So there are how many lateral edges in this particular drawing?
4.
1, 2, 3, 4. Yeah, this one right here, right? This one over here, and then the one in the back. There are the 4 lateral edges there. So it's where the lateral faces meet. That's a lateral edge. So we have a base, lateral face. Yes, it is the one in the back that you can't see. Yes, nice job, Ben. Okay. There would be 4. There'd be 4 lateral faces in this case. Yeah, basically it's this pyramid here, showing like the solid one. So lateral face, lateral face, lateral face, and this right here is a lateral edge.
Just the faces of pyramid.
Okay, we're going to describe regular pyramids now. And most of the figures that we're going to be working with are going to be regular pyramids, but we're going to make sure that we have all the criteria down for regular pyramids. So there's 4 things that have to happen in order for a pyramid to be considered regular. Okay? First one is the base has to be a regular polygon. So write that down. The base is a regular polygon. So what's a regular polygon? Same angle, same sides. Right? Okay, that's a regular polygon. Same. Lateral edges. LAT stands for lateral edges. Must be congruent. Lateral edges must be congruent. So if you take a look at this picture I have over here, these 4 highlighted pieces, those are my lateral edges. Those need to be congruent. So one can't be longer than the other. All right, let's talk about lateral faces. Lateral, LAT is lateral. Lateral faces must be congruent isosceles triangles. Okay, congruent isosceles triangles. So each of the 4 faces in this picture over here is an isosceles triangle, and all 4 are congruent. That's what that means. Just like this picture here. This is solid. This is an isosceles triangle because these sides are the same, and each one of these are congruent to itself. So what I'm holding in my hand is a regular pyramid. Okay, this is what this means. And it's going to fit all 4 of these. The base is a regular polygon. It's a square. The lateral edges are all congruent. And the lateral faces are isosceles triangles that are also congruent. And lastly, all the altitudes, the altitude, the one altitude, meets at the center of the what? Can you guess it? Yep, you got it. All right, the last bit of information that we need to talk about, the part of a pyramid, is called the slant height. Okay, the slant height. So here's what you do: find the base edge. Okay, find the midpoint of the base edge. I have here the midpoint of the base edge. See that little tick mark there? Okay, and what you're gonna do is you're gonna trace along the lateral face all the way up to the vertex. So perpendicular. This right here is called the slant height. It's actually on the face. So if I were to take my drawing here, or take my figure, one piece of random information, the slant height is called L. You tell me why that's called an L? I don't know. Maybe because it's on a lateral side. That's all I can think of. Okay. Now slant height plays a role in calculating lateral area. Nope, this is still part of the same box. I will call out box 7. Don't you worry. Lateral area. What is the definition of lateral area?
The area of the sides.
Yeah, it's the sum of the areas of the lateral faces. Okay, so the lateral area is the sum of all the area of the lateral faces. So the formula for us, in this case, lateral area is going to equal 1/2 the perimeter times L, where L is the slant height. This is something that we need to know. Okay, yeah, so P is the perimeter of the base, and L is your slant height. Okay, so the lateral area, 1/2 PL, perimeter of the base times the slant height, right there. So then, what would then the total area be? The total area would be the lateral area plus what?
Plus
The area of the base, which we'll do in big B. Okay? Big B is area of the base. So this is a very important box. Very important box. The lateral area is just the faces, and it's 1/2 the perimeter of the base times the slant height. And then the total area is that same lateral area plus the area of the base. Okay, so when we're talking about volume, we're talking about how much can fit inside, right? Water, rice, square cubes, right? Since we're talking about volume, what should our unit be in this case? Our unit should be cubed. Very good. So the volume for a pyramid is 1/3 the area of the base times the height. 1/3 area of the base times the height. So big B, remember, represents area of the base. Okay, let's calculate the slant height. I've given you a regular square pyramid. Okay, regular square pyramid, so the base is a square. You know that the base edge is 6 meters. You know that the slant height is 5 meters. The first thing we're going to calculate, the lateral edge is 5 meters, excuse me. We want the slant height. That's what we want.
Oh, I know.
That's what we want. That's what we want.
I know how to find this. 5
Okay.
squared plus 3 squared equals.
Yeah. Okay. Okay, good.
Yeah. Did you find that?
No, we have LA.
Okay. So we want the slant height, right? So here's what we have. So what we're looking for is this piece on this edge from here to here, right? Perpendicular to the side. That's what we're looking for.
Okay.
Okay. That slant height is called L. We'll call it L. How far is it from here to here?
3.
That would be 3 meters. Very good. So I could draw a picture over here that represents what I have. That's L. That's 3. This is 5. Therefore, L would have to be 4 meters because we know it's a 3, 4, 5 triangle. Very good. Okay, the lateral area. The lateral area for us is going to be 1/2 the perimeter times the slant height. Now, the perimeter is the perimeter of the base. Okay? So what is the perimeter of the base?
36.
Let's see here. I have 6 times 4 is 24. So I have 1/2 times 24 times the slant height, which I found in the other example up there, which is a value of 4. Calculating all of that, you should get what? 48 what? We're talking about area
Where'd you get 24?
meters squared. Good question. Where does the 24 come from? 24 is the perimeter of the base.
I did the area instead of
How did you know that the
Okay, total area. How do you find the total area? We found the 2 things that we need already.
Total area plus B.
Yes. Total area is the lateral area plus the area of the base. Have we found the lateral area?
Yeah.
We have, what is it?
38.
It's 48 meters squared. What's the area of the base? It's 36. Very good. 36 meters squared. Therefore, the grand total of 84 what? Very good. 84 meters squared. So we found slant height, we found lateral area, we found total area. We're going to find the height of this pyramid next, which is also called the altitude. Very good. The altitude. Okay, this one's a little bit tricky because you have to figure out where it is. So look at your drawing here. So draw the altitude from the vertex straight down to the center of the base. And then connect it to your to your slant height. Do you see it? So the right angle is made right there. Okay. So we know that the slant height was 4, and we now know that this is 3. You guys see that?
why do we know that?
Okay, wait, hold on. Does everybody see what we know? This is a really tough concept to get. Do you see dropping the altitude? The altitude goes from the vertex down to the center of the base. And then what I did was I made a triangle by drawing out. So I'm talking about this triangle right here. Do you guys see it when I color it in? That triangle is inside the pyramid. Yeah. So now that we've blown the picture up and we have figured out what we're talking about, so let's go over here to height. So the actual triangle, I'm going to take this triangle and I'm going to draw it out over here so you guys can see it. It'll be this. This is the thing that I want, which is, sorry. This is my height. I know that this is a right angle. I know this is 3 meters. And I know my slant height from before was 4. We're talking about meters, right? Meters. So height. So we're going to use Pythagorean theorem. So h squared plus 3 squared equals 4 squared. H must be the square root of 4 squared minus 3 squared. I did a lot of algebra there in my head. Hopefully you can keep up with that, okay? So then I've got square root of 16, take away 9. So h is the square root of 7. Everybody cool with that? Everybody cool with this algebra here? Even though I didn't show it all, you guys can follow? No big deal? So the height of this is the square root of 7. I can leave it in that form. And it's the square root of 7 what? Meters. There you go. And it's a linear unit, right? Because it's the length, so I keep it in meters. I don't square it, I don't cube it. Okay, we've done a lot for this pyramid. I'm going to shrink it down. Look what we've done so far. We found the slant height, we found the total area, we found the lateral area, we found the height. What's the only thing we have not calculated? Volume. The volume. Very good. So we'll do that next right over here. Volume. And we'll do it kind of big because it's the biggest thing. Well, I don't know, it's kind of fun. Okay, what's the volume for a pyramid? 1/3 area of the base times the height. So notice it's a good thing we did this one last because we needed to find the height and we needed the area of the base, right? So calculating all this, I'm going to have 1/3. The area of the base is what?
36.
Very good, 36. And what's the height we just calculated at?
7.
Square root of 7. Awesome. Can I simplify 36 divided by 3? Yeah. So I'm getting 12 root 7 what?
Meters cubed.
Meters cubed. Very good.